larger than that, so farther away from 0.
Okay, first of all, I love both those statements. Do we agree that whatever Bert's is will be larger?
Yeah.
That makes sense. But I want to come back to the first thing you said, which I loved. What does the 1.58 actually mean? What is the 1.58? And this is the problem with that computation. You get lost in the computation and you forget what you're actually doing. Renee, go!
Does it mean that there's actually 1.58 on average points between his test scores?
And give me one more word. I'm getting misty.
I don't know.
So, what were we? We were measuring variance, we're measuring deviation, right? From what?
The average score.
From the average score, Carolyn, thank you. So the 1.58 essentially means if you take all those distances from each data point to the average, and then you average those, that's the number you're going to get, essentially. Now, it's not exact, is it? It's not exact, because if it was the absolute value, it would be exact. But that's 1.2. But you can argue that it's essentially the same thing. And that's why I don't want you to think like statisticians. Think like logical in this case. That's the way I want you to think. I want you to put together what Lauren and Carolyn, or actually what Renee and Carolyn just said. But Lauren, you started it with that discussion back there. If you look at the distances of each data point from average, the sample standard deviation is the average of those distances.
So that shows us it's more consistent.
That's the kick. When you compare standard deviations, the bigger the standard deviation, the more variant, the less consistent. So Ernie's is 1.58. That's a measure of his consistency. Now the problem is 1.58 by itself doesn't tell us anything. We have to compare it to Bert's, which we haven't done yet. Good. You're like, yes, I got that. So 1.58 by itself, standing by itself, you can't say a whole lot about. We need Bert's. We'll come to that, I promise. So we're never going to do it by hand again, I promise you. For a number of reasons. Number one, that sucked. Right? I mean, that was a pain in the butt. Of course it was. Number two, what if you had hundreds, if not thousands, of data points? Do you really want to do that? No. No, you don't want to do that. And you shouldn't do that. This is why we invented computers, to do this crap for us. But the important thing is what Lauren and Renee and Carolyn just pointed out. What does the number mean? That's the important thing. Yeah, anybody can plug numbers into a machine and get a number out. But knowing what that number means is the most important thing. That's why I don't care if you do this crap in your machines. I want you to. But I sure as hell want you to know what that number means when it's sitting in front of you when you're done. That's the most important thing. And to always ask yourself, could I explain this to my neighbor who has never taken a stat class before? If you could explain it to somebody who's never taken a stat class before, you understand it. You understand it. And I love having this graphic up here because it helps so much. As soon as I do this, that's when I start people go, oh, okay, I got it now. Exactly! And you can laugh because it feels good to understand it. This is an alien concept. How many of you have ever, Jacob, I know you have in Bruce's physics class, how many of you have talked about standard deviation before in your classes? Look at that. How many of you talked about an average before you came in this room? Almost every single one of you. But almost no one in this class has ever talked about variation. It's a new idea. But it's tied back to an average. There's an average in there, right? We averaged the sums of the squares. These ideas, this square deviations, is definitely an idea that pops up in statistics. Sometimes it's called SS for sum of squares, sum of square deviations. By itself, I like to ignore it because of the unit problem. The units are off. I love the standard deviation though, because the units are right back. Go, Serenity.
So you were saying that most statisticians use that sample variance.
All of them do.
All of them.
All of them do.
Now, do they break it down into sample standard deviation, or do they leave it in sample variance?
That's up for discussion with who you're talking to. Jacob mentioned something that I used what's called a sample variance. There's also a population variance. I want to come back to that in 5 minutes. As far as sample variance versus sample standard deviation, the sample variance has a very nice characteristic we'll look at in 244 briefly, called unbiased estimation. All that means is, if you were pretending it was a gun of some kind, or a marksman, or a markswoman of some kind, unbiased estimators are basically marksmen that on average hit the target they're shooting for. Biased estimators are ones that on average miss the target that they're shooting for. Here's the kicker. The variance is one of very, very few unbiased good marksmen. The sample standard deviation actually is off a little bit on average. but we can correct for it mathematically, which is all of what Math 244 is how to correct for that offness.
And you can't correct for the sample variance.
You don't have
That
to,
isn't-
it's perfect. You don't have to correct for it, it's already hitting the target on average.
But it doesn't make much sense when you're talking about.
That is why I don't talk about it. Yes, ma'am, that is why I don't talk about it, because the units don't agree. If you're measuring variance in the United States, whoa, I mean, imagine if I'm up there and going, we're off by $14.6 trillion squared. So I figure everybody out, oh my God, squared dollars, it's even worse than we thought. No, it's more meaningless than you thought, because squared dollars doesn't mean anything, right? But dollars does. That's why I focus on the standard deviation. Whatever little bit of offness it has is more than made up for the fact that its units agree with logic.
Yeah.
Thank you, very good questions, right? And I promise you, in 244, we deal with that correction, I promise you.
Oh, I don't take it.
We'll play, you don't have to?
Like, just-
You will. I'll talk you to it. Oh, speaking of which, I just emailed a survey to you guys earlier today too. It's 3 questions, if you would be so kind as to complete it. It's SurveyMonkey, should take you no more than 3 minutes to do. It basically asks you about scheduling of the classes and also where you would like the classes to be, and also if you're taking 244 next year. It just helps us design the schedule better for the next realm of students. So the reason we have this class at 10:15 is because of the results from last term's survey. So please, Lauren,
Question, so if we're gonna take 351 at OSU, do we need to take 244?
which answer do you want for that?
I don't care. I mean, I just want.
No, you don't need to.
Okay. We'll make
Would
it
it be
easier.
beneficial?
Yes, it would. 351, and if I'm getting all my numbers correct, and correct me if I'm wrong, YouTube world, I think 351 is essentially 243 and 244 crammed into 10 weeks.
Okay.
I think. I had to see a syllabus, and I haven't seen one in about a year, so I don't remember. That's why I say it's beneficial, because ideas like confidence, p-values, significance, critical values, things like that, you're not going to learn in this class, but you learn 351, and it goes so fast.
Okay.
That's why I bring it up, so. That's the best
That
answer
would
I can
help
give
me
you.
fill out my survey, that's why I was
That
asking.
good! Very good, very good, very good. Thank you. The best data we can get, the better.